Alright, in this video we're going to solve for the reaction functions of two firms engaged in a Cournot oligopoly. As you have seen in the slides, Cournot oligopoly indicates that the two firms are engaging in a simultaneous quantity competition. Right, so the goal here is to use this demand function and the given marginal cost to solve for the firm's optimal output. Right, and recall that in an oligopoly setting, the output of one firm affects the decision of the other firm. Hence, we derive their corresponding reaction function. So we have assumed that this is your demand function. So definitely this Q, this big Q, is the sum of the output of firms 1 and 2. Right? So therefore, the respective profit functions rather for both firms would be given by phi. Let's denote this phi I equals this is your inverse demand function. So it's pretty straightforward. Just have to plug this back in. So it's A minus B Q1 plus Q2 times Q1 minus C Q1. And for firm 2, you have phi 2 equals, you still have your inverse demand function, so A minus B Q1 plus Q2 times Q2 minus C Q2. Notice that in this profit function, whatever firm 1 does has an impact on the total industry demand, which means that if Q1 produces too much, of course he would get higher revenues, but of course at the expense of firm 2, because he'll be receiving a lower price for his output if he decides not to produce as much. Same goes for firm 1. If Q2 produces too much output, firm 1 will be facing a lower price, and if he doesn't produce as much output, then he'll get lower profit. So we'll derive the reaction function for these two firms by maximizing or by choosing the optimal level of Q1 and Q2 that will maximize their respective profit. So it's going to be pretty straightforward. So you just have to take the derivative of Q1. Here we're going to use partial derivatives already because you have two different quantities. So this is going to be partial of phi 1 with respect to partial of Q1. This becomes A. We'll just go straight to the solution. So this is going to be A minus 2 B Q1 minus B Q2. So notice that even for firm 1, his optimal profit function, or his optimal profit is a function of the output of firm 2. So this becomes C and this equal to 0. On the other hand, you have the profit max condition for firm 2. This becomes, just copy this, just replace the indices, or subscripts rather. Profit for firm 2, so this becomes 2B Q2 minus B Q1 minus C equals 0. Right, so let's copy this. Optimal conditions. Let's duplicate this slide. Just delete this. So we're gonna solve for Q1 and Q2. So that would be the respective reaction functions for both firms. So Q1 star basically is A minus C. But because you have this expression for Q2, A minus C minus B Q2 over 2B. Right. And for firm 2, you have A minus C minus BQ1 over 2B. So this would be their reaction function. So notice firm 1's optimum output depends on firm 2. Same goes for firm 2. And this is simultaneously determined. Now, if we suppose that the two firms are identical. Right? So if they're identical, it means that Q1 must be equal to Q2. And if the two firms are identical, it means that you have the same Q1 and Q2. So if we're gonna look at firm 1's reaction function, it's gonna be A minus C minus B Q1 over 2B. Alright? And then solving for Q1, you have Q2B Q1 equals A minus C minus B Q1. Alright. Maybe we can erase this part already. A minus C minus B Q1, then isolate Q1, so that's going to be 2B Q1 plus B Q1 equals A minus C. Right. Let's add some parentheses here for easier grouping. So this is going to be 3B. 3B Q1. Sorry. 3B Q1 equals A minus C. Therefore, since both terms are identical, Q1 must be equal to Q2. So Q1 star is equal to Q2 or Q2 star, and that's going to be A minus C over 3B. Some textbooks would assume that the marginal cost is 0 for simplicity, but it doesn't make it any difficult solving this kind of problem. So it's just a matter of identifying, or just a matter of practicing your calculus and using the given demand functions and marginal cost functions.